Okay, so let's start with just a quick review of what we looked at just at the end yesterday, and this is in the notes, that arrays can work with methods and functions, methods/functions, okay? Functions, methods, can return one thing, an integer, a Boolean, but that one thing can be an array, okay? So in my notes, I have an example of a method called populate array, which is very similar to what we did yesterday, that will return an entire array. So in the notes, the example of that, how it creates and returns an entire array of integers. So first thing is methods can return an array. Okay? Methods can also take an array as a parameter. So methods and arrays work perfectly together. Just like regular variables, you can pass arrays to methods and you can return arrays from methods. Okay? So that's an example in the notes, slightly different than the one we did in class yesterday. I think the one we did in class yesterday is a little bit better. Okay? Now, one thing about the arrays as parameters is slightly different though. Okay? When you pass an array to a method, unlike a regular variable, if inside a method you were to change that regular variable, after the method is done, the variable would go back to the way it was before. Okay? So I kind of want to just draw this for you to kind of get a better feeling for this. This is known by a by reference or a by value pass. Okay, so say we had this method called foo. Doesn't matter what it does. Let's just say it takes a regular integer called x. Okay? So let's say we said x equals 10, and then we passed it to foo. And let's say inside of foo we had this method, so some other place we had this method foo that takes x, and it makes x into 5, and that's all foo did. Okay? So I say x is 10, so it passes this data along, so that 10 is passed into here. It turns it into 5, right? Well, when the method is over, if I spit out what x is right there, if I outputted it to the screen, it would still show 10 because it was 5 just inside this method. Temporarily it was 5, but by the time this method was done and it comes back to here, this x is different than that x, and so it would still spit out 10. That's called a by value pass. It has passed the value of x into here, not x itself. X itself stays over there. This x over here and this x are two different things, even though they're both called x. But with arrays, life is different. Okay? So say I had this. Int array a equals 1, 2, 3. We learned how to do that yesterday. So there's an array of 3 values, 1, 2, and 3. Okay? And then I said foo a. And then I outputted, I know it's not so easy, I outputted a, which I know would require a whole loop and all the rest of that stuff to do this. Like I'd have to loop through the array and spit it out piece by piece. But if in the method foo in here, I went through the array piece by piece and turned it into 10, 20, and 30. Okay? So I went a spot 0 equals 10, a spot 1 equals 20, etc. When I spit it out here, it would show 10, 20, 30. Because with arrays, when you pass an array, this thing, to the method right here, it doesn't pass a copy of it. It doesn't pass the value of that. It passes what's called a reference, which means it passes the actual thing. So it basically links these two together. It links this one and this one. So in other words, anything I do in here to this one will also change this one out here because they're linked. Okay? And that's a slight difference because arrays are a little more complex than regular variables. They are said to be passed by reference, which means any changes you make inside the array will change it outside the array. And that's what I'm mentioning here in the notes. That arrays are treated as objects like a class, and they're passed by reference. So any change inside the method will be reflected after the method, okay? This is a bit weird because in other programming languages, you can actually do this with regular variables as well. You can make them what are called reference parameters, but Java doesn't allow that, except for arrays and class objects, which we're going to get to in our next unit, okay? So this is starting to look ahead at our next unit, but classes and objects are going to be the focus of our next unit. And we'll see how that also leads into things like graphical programming and object-oriented programming specifically, okay? There's an example in the notes. I'm not going to go through this example. It's a similar example to one we've done, but it also kind of reinforces that idea of reference versus value. Okay, there's also an example in the notes, we're not going to do this one, on how you could search an array, okay? If searching is something you want to do in any great detail, that's going to be a whole unit in the grade 12 course on searching. But the basic search, which I have an example of here in the notes, very simple, is called the linear search, which basically means start at the beginning and look through the whole array. And if you find it somewhere in the middle, stop searching. It's as simple as you would imagine. That is just that, the simplest of searches. There are much more complex types of searches than that. Okay, and in the notes, there's an example of that. So I build an array, I show the array, and then I have a method called find, which searches the array. And this is one version of find. Then I also show a simpler version of find, which is written right here, which is really only 3 lines of code. So this is, if you need a reference, this would be one I might suggest. It's a real simple. It searches the array to search for an item. And it returns what index number it found it at. And if it doesn't find it in the array, it returns -1. Why is -1 a good number if I can't find it in the array? Like let's say an array of three integers, 10, 20, 30. Okay? And if I search for 20, it'll return 1 because I found it at not spot 0, but at spot 1. And if I search for 30, it would return a 2 because I found it at spot 2. Why is -1 a good number to return when I can't find it? Right, there is never going to be a spot -1 in an array because that's before 0, which means it won't exist. So -1 is a good number because it's never going to be a valid spot in the array. Anyways, we don't need to worry too much about that. Searching is a little more of a grade 12 concept. But this is where we get interesting. We're now going to move to the concept of a two-dimensional array. Okay, so I'm going to draw this for you. So far, I've drawn arrays different ways. I've said, you know what? An array could look like this. It's a place where you store memory side by side, right? So 0, 1, 2, 3, 4. That's an array. And I could draw it this way as well. It doesn't matter which way I draw it. To the computer, it doesn't matter. But what if every spot in that array was, in fact, another array? So every spot in the array was another array. Think about what that would actually create. It would create an object that looks like this. Now this object, and it would also be indexed, would be what's called a two-dimensional array. Sometimes refer to this object as a table or an array of arrays, or what the cool kids call it, this is called a matrix. Okay? This is a matrix object. Okay? And again, depending on which math you're taking this year, okay, hopefully, for those of you who are interested in computer science, are taking pre-cal. How many people are taking pre-cal? 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 Okay, good. But as well, you actually can study matrices in math in great detail, especially in grade 12. And it can lead to whole other branches of math. But anyways, we're just going to do this in computer science. And in my notes, I have that. So I talk about how it's an array of arrays, a multi-dimensional array of rows and columns known as a matrix. Okay? It is an array that contains other arrays, okay? But let me try and blow your mind a little bit, okay? So now you know that you can have an array where every piece in it is an array, creating this type of structure. But we don't need to stop there. We could say we could have an array of arrays where every spot in that array is another array. What this will create is a structure that looks like this. To us, to humans, it'll look like this. This is known as a three-dimensional array. Okay? So now you can see the way the computer can store devices in 3 dimensions. To the computer, though, this is all just spots in memory. But for us as humans, we can visualize the 3 dimensions. But as well, you can make an array of arrays of arrays of arrays. You can make a 4-dimensional array and a 5-dimensional array, etc. I can't draw that. I can't draw 4 dimensions on there. I can't draw time. Isn't time the 4th dimension, right? I was just kidding. To the computer, it doesn't matter. It just stores stuff. But again, if you think of, say, a classic example, a 3D game, okay? In a 3D game, you can imagine where they need to track the point of things in 3 dimensions. So in the 3-dimensional world, it might need to know what something is right there in its height, its width, and its depth across the 3-dimensional plane. But as well right there, it might need to know way more about it right there. Like what kind of object is this? How much strength it has? How much mana? Is that a thing? Mana? I've heard that from gamers. There's a thing called mana. I don't know. I don't know these things. But you know what I'm saying? Like there's something there. And that would be where these multiple dimensions could come in handy, is how much data you're actually storing in that spot. We don't have to think of it visually. But by expanding on what we know on arrays, we can get into all kinds of cool stuff. Well, we're not going to do this. We're not going to do any 5-dimensional arrays, but we are going to do a 2-dimensional array. Okay? And I'm just going to show you a quick example, and then we're going to go to code. Okay? So there's the visualization of the 3-dimensional array. Okay? The matrix, which I'm going to start using for 2-dimensional arrays now, can be created by putting the type, the name, and then 2 sets of brackets, not 1 set of brackets. For a 3-dimensional array, you'd put 3 sets of brackets. But other than that, it's created the same way as the regular 1-dimensional array. So here's an example. Here's a matrix of 2 dimensions, 5, 10. And again, these 2 brackets can also be placed after the word int, and I suggest that that's better. 2 by 2 matrix of 5 rows and 10 columns. Now, here's the other thing. Does this mean rows, the 5, and 10 means columns? Or does 5 mean columns and 10 mean rows? To be honest, it doesn't matter to the computer. It matters to you. So as long as you keep it straight which one's rows and which one's columns, then it'll be fine. Okay? You have to keep it straight as a programmer. I might suggest getting in the habit of going rows, columns, rows, columns. But this will also affect other things as we do this. There's no limit to the number of dimensions other than the limit of the memory on your computer system. But you can also, and I don't suggest this, but you can actually even make 2-dimensional arrays like this. This is a tic-tac-toe matrix, 2 dimensions with curly brackets that would essentially build the 2-dimensional tic-tac-toe matrix. Okay? 3-dimension, 4-dimension, all entirely possible. The use of these objects obviously gets more complex as we move up. Okay? Okay. Let's go to the example. Let's go to NetBeans. Whoops. I got the wrong one open. Okay, so here's where we round out yesterday. We had, so far, we had our first array of 10 integers, and we just set one of them to the number 333, and then we outputted spot 3. Then we made an array and outputted it using a method called output. Then we made another output method, or sorry, we made two calls to the output method, and then we made a method called createRandomArray, which sent an array back as a parameter, and then we outputted it. Okay. But now let's get a little more interesting. So now we're going to make a matrix of integers, an int matrix. So we're going to use double brackets to indicate a 2D array called matrix equals a new integer. Okay? And we need to put numbers in those second sets of brackets. So let's use those numbers with some finals. Final, whoops, int rows equals 10. Final int columns equals 20. So this will be a 10 by 20 matrix. And I'm going to use those two finals in the construction of this. Now, I didn't have to do that. I could have just put the numbers 10 and 20 right there. But again, it kind of is a good instance where using constants will help to keep you organized as to which one goes first, the rows or the columns. And honestly, again, it does not matter which way you put them as long as you keep it straight. So by using that, it helps you to kind of organize your thoughts a little bit, that I'm going to go rows, columns, and not columns, rows. So again, you got to imagine the way this thing's going to be drawn. It's going to be drawn with 10 rows, okay, which will be 0 to 9. Okay, and the number of columns going across will be 0 to 19. So this thing will be wider than it is tall. Okay? Now we could make it 10 by 10, which would make it a perfect square, but it's good to experiment with things a little bit that way. Okay? Now let's fill the matrix. Let's fill it up with values. And let's use a method to do that. Let's make a fill method, and we'll pass it our matrix. We'll get to that method in a minute. We'll finish that in a minute. Once it's filled up, let's display our matrix. We'll make a method called display, which will show the matrix. Okay, so we'll fill up the matrix and then display the matrix. Okay, let's now build these two little methods. Fill, and you can use the light bulb to do this, and display. I'm just going to move them up. Here. Okay, does anyone need a minute? Okay, so as we fill up the matrix, we have to travel through it. Okay, the term in computer science rather than travel, generally used, is traverse. We traverse the matrix from its starting point to its ending point. Now, when we did this with a regular array, we were able to use the loop object, specifically the for loop object, to do this. The for loop worked really well for that. But now we're dealing with multiple rows and multiple columns. So in the fill method, we will also use a for loop. But I'm going to suggest we rename the variable I as R, not I. And inside that for loop, what I want you to make is another for loop, a nested for loop. And instead of I for that one, I want you to rename it C. And here's the million-dollar question. Why R and why C? Nope, you don't get to answer. Has to be grade 11. They'll figure, what's that? Rows and columns, that's right. Rows and columns. So now, here's the problem. This is looping through all the rows. There is not 10 rows, and there is not 10 columns. Now, in the top one, we can put matrix dot length. That worked for the previous one. So that'll go through all the rows there. But what do I put here? What do I put, Daniel? That's right. Okay? Glad he's listening. Now, let's stop for a second and take a look at what that means. This is the length of the matrix, which would be the number of rows. But what does this mean? It means the length of that row. Because remember, there's an array within the array. So it's the length of the array within the array that I'm at now. It's a little bit tricky, I get that. You could have also passed the numbers 10 and 20 to here, but it's again using the math there to kind of grasp which dimension we're in, which coordinate we're in. By the way, this will relate to the XY coordinate system, the Cartesian geometry system that you guys are used to a little bit, but not yet. It's not quite there yet. So now what we do is we say matrix spot row column equals, so we need to give it a value right here. Luckily, we already have a method called random integer that will generate a random integer inside the matrix. Shall we go all binary? Should we just make it a random number between 0 and 1? Why not? Let's just make it a binary number. It'll be a random number between 0 and 1. And that's it. That's the whole method. So that whole method travels through the matrix, making ones and zeros, ones and zeros, ones and zeros, randomly. What I then want you to do is copy this code into display and take out that line, because when we display the matrix, we'll do the same thing. We'll loop through all the rows and columns, and we'll output. But what we can't do is a print line, so we have to take it just to print. What's the matrix at spot row column? And we need something to separate it, so I'll go plus a space. Okay, so I'll display a space here. But I need one other thing. When I get to the end of a row, which would be right here, I'll just output a new line character. Or in other words, I'll just do a blank print line right there. Okay, so I went fairly quickly there, so I'm going to go through that code again in a second. But it's not a lot of code there. And I want to show you if it works. I'm going to run this just to see what happens. Okay? On run, you can see right here, I'm getting a 10 by 20 matrix of random integers. And if you want to get really crazy, jack those numbers up. And watch the magic. We've entered the matrix. See you tomorrow, kids.